Welcome to This Explainer. Today, we're unraveling a deadly medical mystery hidden right in our warming environment. We hear a ton about rising global temperatures on the news, right? Usually it's focused on melting ice caps or changing weather patterns. But today, we're actually going to look inward. We're going to examine the very real, immediate, and microscopic damage that extreme heat inflicts on the human body, specifically focusing on some truly groundbreaking new research that exposes an invisible epidemic.
So what actually happens to your vital organs when the world gets, well, just way too hot? Now, what's really interesting about this question is that it bridges the macro-level crisis of climate change directly down to the microscopic inner workings of human biology. We aren't just talking about feeling sweaty or a little dehydrated here. We're asking, what is the actual mechanical toll on your organs when they are forced to operate in environmental conditions they were literally never evolved to handle? Well, to find the answer, we have to look at the people who have absolutely no choice but to work in these extremes.
And we're starting our investigation in Taiwan, where a baffling and honestly tragic statistic points to a severe crisis unfolding right now among rural agricultural communities. Taiwan experiences notoriously hot and humid summers, and researchers noticed something super alarming. Agricultural workers in these areas are disproportionately suffering from end-stage kidney disease. But, why? Farming is undeniably tough work for sure, but it shouldn't fundamentally destroy your kidneys.
So what we're looking at is a very specific, mysterious killer known as CKD-NT. Normally, chronic kidney disease is driven by very clear traditional risk factors, things like advanced age, diabetes, or severe hypertension. But this non-traditional variant, it is totally different. It targets otherwise healthy, active people whose only shared risk factor is working long hours under the blazing sun. To really understand how a hot day in a field leads to irreversible organ failure, a team of scientists decided to actually follow the farmers right into the heat.
Section 1. Tracking the farmers. Let's look at this field study.
To figure this all out, scientists set up a rigorous pre- and post-test model right in the fields, tracking 119 agricultural workers from start to finish on a scorching summer workday. They evaluated the workers before they started their shift, actively monitored their environmental exposure and physical strain while they worked in the heat, and then comprehensively tested them the moment their shift ended. It's an incredibly direct, hands-on way to measure the acute, immediate impact of heat stress. To get this data, the researchers deployed an absolutely intense array of biomedical tools. They didn't just walk up and ask the farmers how hot they felt. They measured the whole shebang with pinpoint accuracy. Participants literally swallowed telemetric core temperature capsules, like they tracked their internal heat from the inside out. They wore chest sensors for real-time heart rate monitoring, and get this, physicians even operated wireless Doppler ultrasounds right there in the muddy fields to look at the blood flow inside the workers' kidneys. They paired all of this with on-site blood and urine tests to hunt for microscopic markers of damage.
Just to help us wrap our heads around the scale of the environmental threat here, look at this number. These workers experience personal heat indexes reaching an astonishing 54.6 degrees Celsius during their shift. That is just over 130 degrees Fahrenheit. It's a staggering figure, indicating extreme occupational heat stress. This isn't just a mildly warm afternoon. This is the human body operating in the absolute danger category, where literally every physiological system is pushed to its absolute breaking point just to keep the body cool.
Section 2. The heat stress toll in one single shift.
Looking at the results, the drop-off is literally undeniable. The data clearly shows how a worker's kidney filtration rate physically plummets as their internal physiological strain index, or PSI, rises. The PSI is essentially a combined measure of how hot their core temperature got and how high their heart rate spiked. It's incredibly clear. The higher the physiological strain on the body from the heat, the steeper the drop in the kidney's ability to filter blood. The kidneys are basically slamming on the brakes as the heat burden increases.
So the crucial point here is that a shocking 20.2%, literally 1 in 5 of these farmers, developed acute kidney injury in just a single workday. Let that sink in for a second. They arrived at work with totally healthy, functioning kidneys, and by the end of one shift under that intense heat, 20% of them met the clinical criteria for acute kidney damage. This proves we aren't just looking at gradual years-long wear and tear. No, we are looking at severe acute trauma happening in a matter of hours.
Section 3. Ischemia, inflammation, and acid. Let's look at the acidification link. Think of your kidneys as a massive water filtration plant. They need a massive, constant supply of blood to do their job, right? But when the body gets dangerously hot, survival mode kicks in. The body desperately needs to cool off, so it forcefully diverts blood away from internal organs and pushes it out to the skin so you can sweat. By doing this, it essentially cuts the power to the kidney's filtration plant. The data showed a massive spike in renal artery resistance for the injured workers. This means the blood vessels leading to their kidneys constricted. Their kidneys were starved of oxygen and blood flow, a condition called ischemia, causing the tissue to literally overheat and sustain damage.
And this ischemia creates a really deadly cascade inside the body. Under normal conditions, you have stable blood flow, relatively neutral urine, and healthy kidney tissue. But the heat stress triggers a domino effect. The extreme heat leads to that reduced blood flow we just talked about. This lack of fluid and blood flow concentrates the urine, leading to severe urine acidification, and that highly acidic fluid sitting in the kidneys acts as a severe irritant, which then triggers massive internal inflammation, releasing damage markers like MCP1 into the system.
And this is the microscopic evidence left at the crime scene. Post-shift urine acidification is directly associated with a steep rise in inflammatory markers. The data proves that as the urine gets more acidic, the levels of the inflammation marker MCP1 shoot straight upward. This strongly suggests that the acid itself might be actively contributing to the tubular injury inside the kidney. It's basically a toxic environment created entirely by the body's own desperate attempt to survive the environmental heat.
Section 4. A global warning. Let's talk about what this means for us.
This powerful takeaway from the researchers reminds us that this data is essentially an urgent distress call. We desperately need better workplace interventions to protect those laboring in increasingly hostile climates. The science is incredibly clear. Working in extreme heat causes acute, measurable damage to the kidneys in a matter of hours. And as extreme heat events become the norm globally rather than the exception, we just can't afford to ignore the physiological reality of outdoor labor anymore. We're going to need enhanced hydration protocols, mandated rest in shaded environments, and active monitoring of physiological strain.
Which really leaves us with a profound and urgent question about the future of occupational safety and our global food supply. If a single summer shift can put 1 in 5 agricultural workers into acute kidney injury, how sustainable is our current agricultural model in a warming world? I mean, these are the people tasked with growing the food that sustains the entire globe, yet they're bearing the invisible biological cost of a changing climate inside their own bodies. It's a fascinating, if sobering, piece of research that hopefully leads to real-world protections. Thanks for joining me on this explainer, and I'll catch you on the next one.